Who? Who's Carrie? Oh, Karan? Karan, if your mother beat you, we're sorry. Okay? Yeah, he is now.
Hey, Karan. Hey, buddy.
Alright. Alright, let's get started. Okay? I want this to be at the same place as this, but it's not working out that way. Alright. Okay, here we go. Okay? Simplifying radicals. Arnold was trying to find some measure of the hypotenuse of a triangle. He found the hypotenuse was 72. Which of the following represents the square root of 72 in its simplest form? Okay? So, when we are doing this, we need to look at the square root of 72 in its simplest form. If you put it in your calculator, you're going to get not what you need. Okay? So, what we're going to do is go back to primes. We have to get this down to a prime number. Remember doing this? Okay, 2 goes into 72 how many times? 36. 2 goes into 36 how many times? 18. 2 goes into 18 how many times? 9. 9 goes into that 3. 3 is prime, right? Okay, so I know I'm going to have something left underneath my radican. So I've got a pair of 2's and a pair of 3's, don't I? So what is left over? The 2. It goes underneath my radican. I pull one of these out and one of these out. 2 times 3. And I get 6 to the square root of 2. My answer is B. Remember doing this? You need to know your prime numbers. Okay, I'm going to give you a hint. When you are simplifying a radican or a radical, the only thing, and somehow this got missed, the only thing that can be inside this radican is a prime number. Okay? Prime numbers. What are prime numbers?
They're numbers that can only have one itself.
All right, so prime numbers are the only multiple multiply to find it. I don't know how to write that.
Find itself.
Is 1 and itself. Example, 1 is prime because 1 times 1 is 1. How about 2 is prime because the only way you can get to 2 is 1 times 2 equals 2. 3 is prime because the only way you get to 3 is 1 times 3 is 3. 5 is prime. 1 times 5 is 5. 7 is prime.
No, never mind.
Not 9, not 10, 11. Okay, and so prime number is the only thing that can be left underneath that radican to get it to its simplest form. Okay, so what is the meaning of the simplifying a numerical radical expression? The value, and this is where they missed it on first period, within the radican
Why am I calling the red in the can?
cannot, because that's what that sign is called, have any perfect square factors. And I'm going to take it further. Number must be prime. Okay? How does the factoring of a numerical expression help in simplifying radical expressions? The perfect squares can be identified in order to simplify the root. The root is what's in, right? Right? All right. Everybody has that written down? Let's flip the page. Laws of exponents.
Oh my gosh.
Ahad. Here we are. The area of a rectangle is 28 to the 4th n to the 5th square units. If the width of the rectangle is 14 n to the 4th, sorry, you can't read that. You need to write to the 4th. Okay. What is the length? Well, let's see here. We know that area is equal to length times width, correct?
Yes.
So, if I need to know the length, I need to solve for length, right? I can divide both sides by what? W, and I will get A over W is equal to length, right? Or if, okay, so I want to solve for length. So I've got A, which is 28 m to the 4th n to the 5th, all over 14 n to the 4th. And I need to simplify this. And by the way, I need all of you to get your mathematics charts out right now. Everybody got one? All right. The reason that they put these laws on your chart is because they don't expect you to memorize them. Isn't there enough that you have to memorize?
Yes, ma'am.
Okay. So this is something you don't. That's why I don't like pockets, Yep. Look at it's falling out on the other side too now. Just sit them on the chair in front of you for now, okay? So you can be paying attention to what we're doing. No, get your mathematics chart out. You need it. For a hod. Just set those up there. There you go. Okay? Now you need to get your paper. You're sitting on your pencil. Poor guy. All right. Okay? All right. So on our charts, all right, the first thing, let's look at our numerals, okay? What do they have? I know that 28 will divide by 14. Do you know that?
Yeah.
And you will get what? 2, okay? All right, so you can mark those off. Now, what do we do? Do I have anything to be able to do with that M?
No.
So I got to rewrite M to the 4th. What about those? And I'm going to mark that off. Now, what about that N? Because it's down here. Do you notice on your chart? Look at your chart. It says that I would do 5, take away 4 if I want to bring that N up. Because I want to leave my exponents positive. All right? So, that's my answer right there. That was hard, wasn't it? Okay. All right. Now, we're going to do 2 problems together because there seems to be problems when doing these. Would you hand one of these? Ian. Ian. Okay. First off, let's turn to page 33. And let's look at number 1. And I want you to write this on here so that you can actually do the work with me. Okay? It says simplify 27x to the 9th to the power of 1/2. Okay? Only because you may have a problem where it gives you to the power of 1/2, and you need to understand to the power of 1/2, to undo that and simplify it, what we're going to do, that is equivalent to the square root of 27x to the 9th. So remember 1/2 is squaring, square rooting, okay, on this exponent laws. All right? Can you remember that? Now, I have this. The next thing I'm going to do is, because this is multiplication, do you agree? I can do this if I want. That's the same thing. All right? So I'm going to look at this number 27. And I'm going to say 27, and I'm going to divide. Does 27 divide by 2? No. Does 27 divide by 3? Yes. And I get 9, and then I get 3 and 3, don't I? Okay? So I'm going to pair up my 3's. I'm now going to come over here and put 1 3, and then I'm going to put 1 3 under that was left over. I take one of these out and put it on the outside because that's a perfect square, and then I take my 3 and put it over here. And that is a prime number, isn't it? Okay? Now, what are we going to do with these x to the 9th? Can I do this? 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that the same? Okay. X times 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 x 9 times is x to the 9th, not 9x. Okay. We all agree upon that, right? So why can't I do this? There's a perfect square of x's. There's an x squared. There's an x squared. And there's an x squared. Do you agree? So how many x squareds do I have? 1, 2, 3, 4. So I can come out here and put x to the 4th. And how many x's are left for the inside? 3x. So my answer is 3x to the 4th times the square root of 3x. Okay. So your answer is B on your paper. Okay. The other thing that they didn't remind you of very well with the example that they gave you, and I'm just going to write it down here. Okay. Remember that to bring something up, you're subtracting, and to bring something down, you're what?
Adding. Dividing. Multiplying.
You're adding. Look at your exponent rules. What does it say? Okay. So when I have m to the 4th over m to the negative 3rd, and I want to leave it positive, it's like saying m to the 4 plus 3, which is m to the 7th. Okay? If I have m to the negative 4th over m to the 3rd, I would want to bring this 4 down. It would be like saying 1 over m to the 3 plus 4, which is 1 over m to the 7th. Do you see that?
How would it be 1 over?
Because you have a 1 here regardless, right? So it's my 1 is left because I'm taking my 4 because I want to leave my exponents positive. Okay? The other law that they don't show very well is, what if I had m to the 5th squared. That's like saying m to the 5th times 2, which is m to the 10th. When it's outside that parentheses like that, you're multiplying. When it's not, you're adding. Okay? Now, what if I had m... Let's see. I think that's... I'm out of lead! Alright. Last thing that we need to go over, because people were struggling on page 29, number 1. So maybe take your notes on the other side, and if you have a spot, you can do page 29, number 1. Okay? Alright. What is the area of a square? The area of a square is 1,125 inches squared. What is the length of the side in its simplest form? Okay? First off, I'm going to tell you this without even doing it. If you understand what prime numbers are, there's only one answer that has a prime number underneath the radicand. Okay? So, but we want to prove that that's actually the truth. Okay? Remember that side times side equals the area of a square. This is what you need to remember. And side times side is like saying side squared, correct? How do you undo a square? So if you take the square root of a side squared, don't you get a side? Okay. So if I have area, I have side squared is equal to 1,125. Do we agree? And I want to know what the side length is. I take the square root of both, and I'm going to find out what the side length is. Do you agree? If you put that in your calculator, you're not going to get the answer you want, Wesley. Okay? All right. So I can take 1125. And, okay, I could start out with 2, but I know that 5 is going to go into it. So let's do 5. 5 goes into 1125 how many times? 225. And 5 goes into 225 how many times?
45.
What?
45.
45. And 5 goes into 45 how many times? 9. And 3 goes into 9 how many times? 3. And 3, right? So I've got here a pair of 3s, here a pair of 5s. So I've got 5 times 3 times the square root. What was left? Of 5. So it's 15 times the square root of 5 is my answer choice. Okay? You're going to do 1 and 2 like that. All right? Okay? And like I said, if you know your primes, it'll make this a lot easier. Okay? Any other questions? So your answer choice here was D. Okay? All right? All right. If there's no other questions, that's the end of the lesson for today. You know, if anybody ever watches these videos other than Quran, they're going to be like,
I did it once before. I was towards the